Hey guys, today we're going to be talking about exponents. Now, exponents are usually written like this. You have a number here, let's say x, because it could be anything. And then your exponent is written right up here in the corner. So this is your exponent. I'm going to go ahead and label that. And then this number, whatever it is, whether it's a variable like x, or a 1, or a 2, or a 7, or a 90, whatever it might be, that's what we call our base. So your big number is your base, and the number up in the corner is your exponent. Now let's do an example. Let's say 7 to the second power. That's a way that we could verbally talk about an exponent. 7 to the second power, or maybe to the third power if it was a 3 up there, or the fifth power if it was a 5. We also have the shorthand way of saying squared if it's a 2. That's something you're probably going to hear a lot. So here's what this means. An exponent tells us that we are going to take this base number and multiply it by itself this many times. So this means we are taking 7 and multiplying it by itself 2 times. So 7 times 7. Now to just give a further example of that, if it was 7 to the 5th, then we would be multiplying 7 by itself 5 times, such as 7 times 7 times 7 times 7 times 7. Now the really important thing to remember, because it's a very easy mistake to make, is that the number is not multiplying the exponent. It's not 7 times 2, and it's not 7 times 5. It is 7 times itself that many times. Now if we wanted to actually turn these into whole numbers, we could just do this multiplication, right? We could say, well, 7 to the second power is 7 times 7, and 7 times 7 is 49. We did it. You could do that same thing here. Now, I don't know how to multiply 7 5 times in my head. That's going to get us a pretty big number. I can't do that on the spot, but I bet your calculator can. You could say 7 times 7 times 7 times 7 times 7, type that in there, and you're going to get a very large number, but that's what this is equivalent to. So this is how exponents work. Now sometimes you might not see it already written as an exponent. You may see something like this and you may need to write it as an exponent. If that happens, or in that scenario, if you see something like 5 times 5 times 5 times 5, and you're told, hey, write that in exponent form, or exponential form, you may hear it as well, then you can actually do that by recognizing, well, the number multiplying itself must be our base, so our base would be 5, and then the number of times it's multiplying is our exponent. Well, how many times is it multiplying here? 4. So this would be 5 to the 4th. Now, occasionally, well, more than occasionally, quite often, we use exponents with variables as well. Let's say we had an equation that said x times x times x times y times y. We could write this in exponent form the exact same way we would a number. Even though these are letters or variables that we don't know what are, they still work the same way. We could look at this and say, okay, well, how many times is x multiplying itself? How many x's do we have there multiplying? Well, we have 3, right? So that would be x to the 3rd. X times x times x. Do we have any other variables multiplying themselves? We do. We have a couple of y's here. So we had a base of x, and it was multiplying 3 times. And now we can have a base of y, and how many times is it multiplying? 2. Exactly. So that works the exact same way as it would with regular old whole numbers. The last thing I want us to talk about in this video is fractions and exponents, because fractions and exponents are kind of weird. They're unusual. Let's say we had something like 1/3 to the 2nd power. How would that work? Where does that 2nd power even go? What's multiplying itself? It's weird, right? Well, we know that if our base is the fraction, if our base is 1/3, then what that would mean is we're taking 1/3 times itself 2 times. So you could look at it like that, 1/3 times 1/3. And we know how to multiply fractions, so that's a pretty easy problem for us to do. We get 1 times 1, or 1, over 3 times 3, or 9. Great, we're already done. There is another way that you can do exponents with fractions, though. What we could do is actually take this exponent and apply it to the numerator and the denominator, meaning that we could instead see this written as 1 squared over 3 squared, or 1 times 1 over 3 times 3. 1 times 1 is 1, and 3 times 3 is 9, right? Exactly. Now, you're probably thinking, that was easier. We were just multiplying 2 fractions. I'd agree with you. This is probably a situation where we'd want to do it through just multiplying that fraction by itself. However, we have some problems where those exponents get a little bit bigger. You know, let's say maybe you have something like, 3 over 4 to the 4th power. Well, I mean, technically, that would be our base number, 3/4, times itself 4 times. So it would look like this, right? You'd have to multiply 4 fractions straight across the top every time. You could do that. Or you could look at this as saying, well, that exponent, I apologize about the bell there. You could say, well, that exponent goes to the top, 3 to the 4th, and the bottom, 4 to the 4th, and then you can just type each of those into your calculator if you wanted. Now, I'm not saying that's how you have to do it, but you can. That is an option. And this is how we would write that. So these are kind of some of our basics about exponents. We're going to have a second video, and that video is going to talk about special case exponents, such as exponents that are zeros and exponents that are negatives. If you're curious about those, keep an eye out for that video that's going to be posted here pretty soon. Otherwise, if you have questions about this, drop a comment below, and I'll get back to you as soon as I can. Thanks for watching, guys.